G'day Bifrosters. Sorry I've been a bit quiet lately, I haven't been well. Today we're going to go through the second of the copy to nodes, copy to point. This is a little more difficult, but a little more rewarding as well. So here you can see the results. I'm going to go through it as I do with the ones that I'm not quite sure of. I'm going to go through it first and then I'm going to rebuild it with you. So here's the results of it. What this is doing is it's taking in a geo, which in this case is a mesh cube, which is what you can see on the points. And it's taking in the points and the normals from another object. In this case, the Shire horse here. So it's updating his normals, and then just points and normals are coming into here. And there's some options on here. One's an up axis, so that's to get the rotation of the points along the normals. You can see that the cubes are all pointing along the normals. Let's swap that out just quickly with an octahedron. Create that. Drag it in. Just having a little think, and then we'll just plop that into here, and possibly here. That's well, there we go. And what I might do is I'll just scale this down a bit. So you can see if we zoom in or scale up a little bit more, I don't know why it keeps popping back to cubes for a little while, I'll get to that in a minute. But you can see here that these are all pointing along the normals. If you look at the way an octahedron is constructed, you can see that this little apex point is always pointing along the normals. So that was the hardest thing to get in this. So let's quickly run through how we do it. We'll just close this down, and then we'll have a crack at building it. Here's our geometry coming in, and that is plugged into the point create instances. So this is the geometry that we're going to instance on the points. Now this can be more than one geometry. It doesn't have to just be the one, it can be an array. You can see the little array hat there, and I will, when we build it, I'll set this up to be an array. Then we've got the positions and the normals coming in, and the positions first go to construct the point object, which has its orientation set by these little nodes up here. And what these are doing, these compounds, and this is how we get it to point along the normals. So we have the positions and the normals coming in, we have the positions coming straight in there, and then we add the positions to the normals and plug them in here. And what this does is it gets a unit vector, so a vector with a length of 1 along that along that normal. So the beginning of the normal, which is the position, and the end of the normal, which is the position plus the normal. And it outputs a normalized vector, which is why it's a unit vector. And then we do an aim and up to quaternion, quadrophilia, I'm not sure. Anyway, so what this does is it goes in here to start with. We get this is where we set our up axis here. That comes in from the input, and at the moment I'm using world up, which is just 0, 1, 0. So we take our aim, which is the result of this, the distance unit vectors, and our up. And first what we do is we do a cross product of the two, and then normalize that by dividing by its length, and then we output that. And that is our axis. So that's a vector coming out. It's the axis around which things rotate. Then we take them both into another one where we get the dot product and the a cosine of that dot product, and that gives us the number of radians to rotate around that axis to get this. We output that, comes back down here, and that sets our point orientation, which is the rotation of the points, which which then transfers to our instances, and we get that they end up pointing along the normals. That's basically the node. I've added a condition in here to bake the geometry. If we wanted to have polygons come out, we can bake it, or if we don't, we can just have the instances come out. I've left it on instances because it's super fast. But that's essentially the copy to points node. As long as, if you don't give it normals, like this, it'll have a little think, and then everything will go back to pointing straight up. So you can see that they're all aligned the same way. They're all pointing that way. Undo that. Goes back to cubes for a second, for maybe for a bit longer, and then it pops into the, I'm not sure why it's doing that, but that's okay. So that's essentially the run through. Let's just go ahead and make it. So I'm just going to start a new graph because I may need to refer back to this one now and again. And once more, I'll bring in my horse. That's my horse shape. I'm just using my horse to get his points. We'll bring in the platonic shape that we made before. Let's just output these to make sure everything's happy, and I'll hide the first Bifrost graph, like so. So you can see straight away, if we just turn this off, that there's something wrong with our horse, and that's because this is still visible and this is still visible. So here's our horse. The first thing we need to do for our horse is to make sure the normals are right. So we're going to update mesh normals. There we go, that's much nicer. Then what I want to do is get the point and the normal of this, because this is going to be the points upon which we copy our geometry to. So I use my own node. But again, if you wanted to remake this, this is nothing more than get a point position, get a point normal, and output. It's done for convenience because I'm lazy. I'm a lazy artist, and I'm not ashamed of that at all. Makes things faster. So now I've got my points and my normals. Let's prepare our two positions. Our first position is this. The second one is going to be, so that the point position is always the beginning of the normal. The point position plus the normal is going to be our aim position. So we'll just call this. And let's stick these into a compound. So this is going to be our normalized unit. Normalized unit vector distance. So we get our point positions in first, and I like to name things so that I know what's going on later, or I've learnt to do that since starting to make these tutorials. Okay, so this just becomes a subtraction exercise, and what we want to do is subtract that from that. So in with a subtract node like this, and then we normalize the result. And that's our first bit done. So we've basically, what we've just done here is we've taken our point position and our normal, and then gotten the vector between them and normalized it. That's all we've done. Going to go and refer to my other graph now. Now we do the aim and up to quaternion, qualification, whatever it is. We go back to our other one, so we make another compound. This is going to be aim up to quat. So this, I'm going to rename to normalized aim, so we know it's the aim. And then I'm going to make just a vector here. I just thought I was deeper into the graph than I actually was. I'll just change that to 1 for now. We'll go in here, so we'll make a new compound. We'll stick them both in there. Inside here, we'll put a cross product. Like this. We'll get the length of that cross product. We'll divide the result by the length, which just it's normalizing it, and out we go. So this is the axis about which we're going to rotate. Back up, make another compound. Like this, and then both of these are going to go in here. Here we need a dot product. So we'll dot product those. a cosine, which goes into here, and this becomes our angle. Let me just quickly double check I've got this right. Yep. And now we just need an axis angle to quaternion, qualia. I really don't know how to pronounce this. 4-point rotation thing. So this is going to become the rotation we need to point along the normals. So that's that prep done. So now we take our point positions, which is this guy, and we make a point object out of it. Construct points. And then we set point orientation. Maxime, you're a wondrous man. You're a wizard. So I'm just going to change this to point orientation. And then the output, the quaternion, qatar, goes in here. Says, and now we're ready to instance. So, do set instance geometry. No, I'm not. I'm going to do create instances. And this is where everything comes together. Thank you for being so patient. So this becomes our points. That's what we're going to instance on. This guy, back up here, basically gets plugged into this, but let's do a little bit of housekeeping first. So let's split these guys out so they can all be separate. I'm just going to make a compound out of all of this, like that. Do a little bit of cleaning up because we've got positions and normals all over the show. What are you? I think your positions as well. Let's get you in there. We'll just leave our instances for the moment. So now we've got to plug in what we want to instance into this compound. I'm going to plug this guy in, but I'm going to make very sure that my port type here is object, it's an array, and then fan in is switched on. So now I can plug different objects. I can plug an array of objects or singular different objects into this. Let's get our, let's just do throw a mesh cube in there as well, just for giggles. We'll make that smallish. We'll plug that in there as well. So we've got two objects being instanced, just to make sure that this is working. We take this whole array, plug it into the instances, and let's plug the instances into the output, and let's plug the output into something we can view it on. And that's kind of looking right. Not entirely sure about my rotations. I'm thinking maybe I should turn on my horse and have a look. Yeah, my rotations are off for some reason, which I'm going to have to go and check out. But mainly that's working. I have a feeling that in here what I might have done is plugged the wrong things into the wrong things. Like specifically in the subtract here. So we'll just try switching this around. Nope. We'll maybe have a look in the other one as well. Bear with me a second. Oh, you know something? Did I didn't hook up my up axis, did I? I did. What happens if I change that up axis? Things do change. Up axis into the cross first. There we go. So I just had some of my connections around the wrong way, specifically this one in the input to cross product, but now, I mean, that makes a bit of a mess of his poor old face, but you can see that they're now pointing out along the normals. So the last thing to do, just to finish this off, is to enable the baking of instances. So we'll pop that up there, and we'll just do an if statement. Meshes is what we're after. Our false case is to remain instances, and we'll take the condition, pop that down the bottom, bake instances. So let's do some renaming and tidying up. Positions in, normals in, instance meshes, and let's just grab this guy and get up one, compound, and we will. Now we can just, if we wanted to, add a facility to put this node inside as well, the positions and the normals. I've left it split out because this way, if you don't have any normals, it still works. Everything just points the wrong way, but it still works. You don't have to go delving into a published node to find out if there's no normals. You can do it outside here. You can also change the normals, which will change a couple of things inside, but the aim part of it, which is all of those dots and crosses and acoses and things that we did with the up axis and stuff, that'll remain the same because it's really just aiming one point at another, and to get those points I'm using the length of the normal. You can change the length of the normal, but the aim shouldn't change at all. So basically that's it. That's copy to points, like so. Again, if you wanted to expose more of your controls, for example, you have a fair few instance controls here, can make it more of a random distribution of those. I can change the distribution so that we get almost none of one and most of the other, or whatever we want to do. And if you're instancing different objects, that can be very helpful. So you could expose that as well. You could change this, change that to instance geometry, so because we're not doing anything too heavy right now. Yeah, too many arms. So I hope this has helped. This is just to give you a really quick example. This will also work on something like, so I've got points in a sphere, which is an object I made. So if I just go, it's a node I made, not an object. If I just go to PNT display, which is another one I made because I'm lazy, I want to have a look at that. There they are. There's some points in a sphere. They are random. They are in a sphere. Everybody's cool. You can use this. I know you don't like working when you've got nothing plugged into you. So I can put my points in here. You can see all my instance changes. I can put my generated normals in here, and now they're all pointing outwards along the sphere. So it doesn't just have to work for meshes. It can work for anything with points. If you can make normals for them, you can get a name along the normals. All right, cool. Well, I hope this has helped. This is another attempt to slowly take over Houdini. Yeah, hopefully this has all helped you guys, and I'll see you next time. Thank you.